Hello students, this is the recording that goes over the remaining slides for the Unit 1 Chemistry project, the food project. All right, so we're taking a look now at slides 9 through 18. All right, so slide number 9 is taking a look back at our mind map for how we can classify matter. Remember, we talked about mixtures and pure substances. We said that if something cannot be separated physically, that makes it a pure substance, whereas if yes, it can be separated physically, then it is a mixture because mixtures are only physically combined. Of the pure substances, then we then talked about can it be separated chemically. We said elements cannot, right? And so they are things like gold and oxygen. Remember that these are all made up of a single type of atom. Whereas over here for compounds, we said yes, these can be chemically separated if they undergo a chemical reaction because they're made up of different atoms, right? For example, water is made up of H2O and carbon dioxide is made up of CO2. Now over here in the mixture area, we talked about is your mixture uniform? If yes, meaning every sample looks the same, every sample is the same, then that is going to be a homogeneous mixture. Remember that prefix right here, homo meaning that they look the same. So that would be something like salt water or sugar water, really any type of liquid where it looks the same. Every sample looks the same. Over here, heterogeneous mixtures, every sample looks different, at least a little bit. Every sample looks a little different. All right, so a good example right here that we talked about in class is wood, how every slice of wood is going to have like a different number of knots, different rings, different colors. The outside bark looks different than the inside, etc. All right, so that's any type of mixture where it's not completely uniform, not completely the same. So let's go ahead and talk about how we're going to apply this to our project. This is very similar to what we did with our solid, liquid, and gas with our project, so this should look very familiar. Let's go ahead and take a look here. What part of your project's food is a homogeneous mixture? Again, these are going to tend to be things like sauces. So taking a look here. This is going to be anytime you have a sauce that is pretty uniform, right? A uniform sauce, right? So like a cheese sauce, or this could be like salt water that you used to boil something. This could be like a broth. The broth is has the chicken stuff in it, but it's pretty uniform with the liquid. This could also be, it tends to be any liquid that looks the same throughout. Okay, again, if you have trouble thinking of something, always go ahead and email, text, or go to office hours if you need help figuring out your specific food. Okay, all right, so those will all be examples of homogeneous mixtures. Again, mixtures that look the same throughout. So remember that the definition of a homogeneous mixture is it is a physical combination where each sample looks the same or uniform. Okay, so feel free to use that same definition. All right, so you can say that I know this because each sample of my food looks the same, right? Okay, so let's go ahead and then take a look at heterogeneous mixtures. Again, very similar kind of process here. You need to identify your heterogeneous mixture. So heterogeneous mixture is going to be pretty much everything else, right? So this could be something like pizza toppings, right? Which you have different types of pizza toppings. This could be like your noodles mixed with your sauce, because if you take samples of noodles and sauce, you'll get different numbers of noodles, different amounts of sauce, etc. This could be like your seasoning inside of your broth. Your seasoning doesn't dissolve perfectly, so each sample will have a little bit of a different amount. This could be like, for example, your meatballs, right, have different amounts of stuff in each sample. And the outside looks different than the inside. This could be like a cookie, right, outside, or you can say like the bottom looks different than the top. the top, etc. So anything that's mixed together that is not perfectly uniform. Anything mixed together that's not perfectly uniform. And again, our definition of a heterogeneous mixture was that this is still a physical combination where each sample looks a little different. And so you can talk about how each sample looks a little bit different because like you'll get different amounts of ingredients, or the top looks different than the bottom, etc., etc. Okay, so make sure that you kind of take that definition, and then just make sure you, as you're talking about how you know this part is a heterogeneous mixture, make sure that you include this definition of it's a physical combination where each sample looks a little different. All right, it's not uniform. Okay, so that is your heterogeneous mixture. Again, if you do need help identifying that, make sure you communicate with your teachers. Taking a look at slide number 12 then. Slide number 12 is talking about elements. So what part of your food is an element? And you can see right here that we have our periodic table of elements if you need to refer to what all the different elements are. So remember, we learned about how all of these are elements. They are made up of a single type of atom. Hydrogen cannot be broken down into anything besides hydrogen. Carbon is carbon, helium is helium, oxygen is oxygen, etc., etc. Now the tricky part is here that everybody is going to have basically the same answers. So everybody's food has air in it, and air is made up mostly of nitrogen and oxygen, and oxygen. Nitrogen, N2, and oxygen O2. Okay, you can see a picture of that oxygen right here, O2. Okay, so you can choose either of these. You can either choose nitrogen or you can choose oxygen. All right, so only choose one. Only choose one. Do not say air. Do not say air. Okay, air is not an element. Okay, you have to either say it's nitrogen or oxygen, and in the air, right? Nitrogen or oxygen from the air. Okay, and how do you know this? Again, definition of an element, you should be able to say that this element is in the air and it is made up of a single type of atom, and you should be able to identify that type of atom, right? Is it only nitrogen, only oxygen, etc., etc. Okay, so that'll be your element. Taking a look at our compound right here. What part of your food is a compound, and how do you know this? Remember, we talked about how compounds, taking a look over here, compounds contain two or more different types of atoms. Now, I actually do have a website here that will give you lots of different ideas. So if you click on this website right here and scroll down, you'll be able to see some examples. So first off, you can see water. Right, most of your food will have water made up of H2O. That's hydrogens and oxygens. Those are different elements. Ascorbic acid, vitamin C might be found in your food if you have a type of food that has a lot of vitamin C. Carrots, for example, have carotene in them, beta carotene. That B stands for beta, and that's made up of carbons and hydrogens. So you can use that example. Some other examples, if you keep on scrolling down, are glucose, which is a specific type of sugar. Sucrose, if you have just regular sugar in it from like your kitchen, sucrose is C12H22O11. Lactose is found in milk. All right. Linoleic acid, baking soda. Right, so a lot of these you can see, does my food have this? Does my food have linoleic acid? Does my food have baking soda? Baking soda is also a part of baking powder. So that's sodium, Na, hydrogen, H, carbon, C, and 3 oxygens, O3. Starch, so a part of flour, if you have flour in your food, that's going to be C6H10O5 with a little N. N just means you could actually have a lot of those. C6H10O5 molecules kind of linked together. If you have butter, there's palmitic acid in butter. Here's the chemical formula for palmitic acid. And salt. Everyone's pretty familiar with salt. Salt has sodium and chlorine, NaCl. Those are two different elements. All right, so you can choose any of these, or if you want to actually look up, you can actually Google. So either use this website or just Google what chemicals are in my food, and just what is your food, right? So you can actually look at what compounds. Don't say chemicals because you'll get weird stuff. So what compounds are in my food, okay? So say what part of your food is a compound. Make sure to give the actual chemical formula, right? Like we were talking about, H2O, right? So, right, C12H22O11, right, H2O, beta carotene, C40, H58, so salt, NaCl, etc., etc. So give me both what is it and the so actual chemical formula and normal name, like salt. Okay, and then go ahead and you're going to explain how do you know that. Again, the reason you know it's a compound is because it's made up of different types of atoms, right? It's made up of different types of atoms, and explain what are those atoms. So this atom, and this atom, and this atom, etc. Right? So you would say, for example, water is made up of hydrogen and oxygen atoms, okay, which are different types of atoms. That'll be your compound. All right, the last thing we need to go ahead and take a look at is talking about a phase change that occurs in your food. Everybody has a phase change because everybody should have heated their food. So remember, everyone's food should have been something that was heated, right? And there are many different ways to heat your food. It could have been grilled, it could have been microwaved, it could have been on the oven, on the stove, it could have been deep fried, etc. Everybody had food that got heated up. Okay, so in that instance, this is going to result in a few different things. It could result in your food either melting or your food evaporating. Okay, so we'll go ahead and take a look at that in just a moment. Remember that when we talk about those different kinds of things, right, vaporization and melting are the main ones. These ones, your temperature increases, right? As you become a gas, you get very hot, or as you become a liquid from a solid, you do get warmer, right? So you're getting hotter, or warmer, temperature is increasing, and your molecules are also moving faster. So a gas has very chaotic particles, they're moving very fast. Liquids, they're not as chaotic as a gas, but they're definitely they're moving more than a solid, right? Remember that liquids can flow, right? Liquids can flow, gases are chaotic. And so in order for all of this to happen, they must have absorbed heat, or thermal energy. So we can see it's absorbing heat, thermal energy is going into it, and therefore these are all endothermic processes. So vaporization and melting are both endothermic processes. So that's exactly what should be happening in your project, right? Is that you are getting temperature is increasing, particles are moving faster, heat went into it, and therefore it should be endothermic. Okay, so regardless of if you choose vaporization or melting, those are the two choices you should be choosing for your project because everyone heated up their food. Regardless of which process you use, the same concept is true. Temperature increases, particles move faster, heat went in, making it endothermic, enters. Heat enters, endothermic. All right, so make sure, take a picture of this because this will help you on your next slide. So this is going to be our answer over here for, I believe, slides number 12. So make sure you have a picture of that, okay? All right, so moving on, slide number 16. What part of your project's food underwent a phase change? So here we go. There's a lot of different options, right? So you could have things like melting. That could be things like butter. That could be things like cheese. Let's see here. What else is things that melt, right? So if you added ice cubes to a pan, those will melt, etc. Okay, so you could have melting, or you could also have vaporization. So vaporization mainly would mean that everybody has some water. Everyone has some water in their food. So when it is heated, it begins to steam. Okay, so you should be able to say my butter melted, right? So my blank underwent the blank phase change, the melting phase change or the vaporization phase change. Okay, so taking a look here. Oh, sorry. You can actually here, you only have to put which part right here, right? So you can say my butter, my cheese, my water, and my food, right? So you could say any of those, okay? Then you're going to go ahead and say what state did it start as. Remember that for melting, melting starts as a solid and ends as a liquid. And then for vaporization, vaporization starts as a liquid and ends as a gas. All right, so whichever one you choose, right, if you chose something that melted, your starting state should be a solid, your ending state should be a liquid, and you should say this is melting. If you chose the fact that everybody's food had water and it got heated, so everybody has at least one answer here. There's no excuse. Everybody should have one phase change because everyone heated their food. Vaporization, you would say it started as a liquid and then ended as a gas or steam, and therefore that is vaporization. Okay, so easy peasy. That is slide number 16. Taking a look at slide number 17, we just mentioned the answers to slide number 17. We said, did temperature increase or decrease in your phase change? So remember that for both melting and vaporization have the same should have similar changes in properties, right? So, right, we talked about how melting and vaporization, you're ending either as a liquid or a gas, which is going to be hotter, so temperature is increasing. We talked about how in order for that to happen, thermal energy had to be absorbed into it, and therefore what type of right, we added heat, right? We added heat through the stove, oven, grill, microwave, etc. All right, and therefore, what is that going to be? Endothermic or exothermic? You should know that, right? If heat enters, what is that going to be? Endothermic or exothermic? And then again, think about if it's ending as a liquid or a gas, right? Liquids can now flow. Gases are now chaotic. Think about what that means for the motion of those particles, of if those particles are decreasing or increasing their motion. Again, we just went over the answers together on slide 15. So if you go back to where we were talking about slide 15, we actually went over those answers together. Okay, let's go ahead and talk about your conclusion. Talk about one thing that went well for you, one thing that you could do to improve. Keep in mind that saying I don't know, I don't care, nothing, etc. Those are not appropriate answers. I do need you to be specific and reflective. Let me go ahead and show you now how to submit your project. All right, so if you downloaded your project already as a PowerPoint, you don't need to go through this extra step. But if you are in Google Slides, you do need to download your project to your computer. So to do that, you go to File, Download, and then download it as either a PDF or a PowerPoint. I actually prefer PDF. PDF seems to keep your project looking much nicer, so I would prefer you to download it as a PDF, but you can download it as a PowerPoint if you don't have PDF. All right, so I'm going to go ahead and show you how to download it as a PDF. Make sure you save it in a file that you can find it. So for example, I'm going to save it in my project file. All right, and then I would recommend just open it up and make sure that everything looks good, that it all looks like it's supposed to look, that all the text is on the slide. If you have text off the slide, I won't be able to read it. Okay, so let's go ahead and then go to our course page, and we'll go ahead and we will actually submit this. So let's go ahead and show you what that looks like. All right, so you're going to go to Tools and Assignments. So again, this is after you have downloaded after downloading your project. If you used Google Slides, PowerPoint is already downloaded. Okay, then you're going to go to Tools and Assignments. So Tools, Assignments. And from here, you'll see the Unit 1 Food Project folder. So Tools, Assignments, and then go to the Unit 1 Project folder. Okay, and you're going to want to go ahead and scroll down. So scroll down to where it says add a file and follow those instructions. Okay, so let's go ahead and take a look at that. We're going to go ahead and click add a file. You're going to want to get it from your computer. So add a file, my computer. Okay, and then you're going to go ahead and click upload and get it from your folder. So here's my copy of my chemistry project. And then you can go ahead and click add down here. All right, so again, we go to add a file and then your computer, from my computer, and then upload, find your file, and then click add. So just follow those instructions that follow the instructions that this module gives you, and click add, and then just finally go ahead and submit, and then you are all set. All right, thank you everyone. Again, if you do need help on anything, please let me know.